Something that has become an important topic recently has been the idea of journal metrics. And journal metrics are being used in order to assess a journal's quality. Sometimes the word quality needs to be defined here, and quality in a journal metric, in terms of a journal metric, is dependent upon how the journal metric is calculated. So it's important to know what these journal metrics are because they can help you understand at least some component of what quality means. So as you're thinking about this, this video hopefully will help you understand how to find these journal metrics and make more sense of what they mean. So let's start here with the basic Google search. So one of the more simple metrics to understand is Google's H5 index. So if you go to Google Scholar and you click on this little 3-bar thing in the top left, and then there is a section called metrics, and you click on that. The first thing that it's going to do is show you the top, I don't know how many, 100 journals that exist, period. These are all research journals, so they aren't necessarily related to education. So if you look at the top one here is Nature. Nature is a hard science journal, and you can see there are two metrics listed at the top, an H5 index and an H5 median. And let's talk about what both of these are. So if I click on H5 index, it says at the top, H5 index is the H index for articles published in the last 5 complete years. All right, now there's a further specification here that in order for Google, at least, to provide this number as a metric for a journal, it will require that there be at least 100 published articles within the last 5 years. If there have been less than 100 articles published within a journal over the last 5 years, then this value will not appear for that journal. That doesn't mean that the journal does not have high standards or put out high quality work. It just means that Google felt as if there was not enough data to provide a good measurement, so they don't provide that metric. It could be calculated by hand, but then you have to trace down all the articles that have been published over those 5 years, along with how many times those articles have each been cited. So let's look at what this does. It says it is the largest number H such that H articles published in this case right now, 2014 to 2018, have at least H citations each. So let's take the journal metric, or the journal Nature, for an example. The H5 index is 368. So what this means is that they took the journal Nature and they took all the articles that have been published in Nature in the past 5 years. And then they figured out how many citations each of those articles has within that journal over the past 5 years. And then they sorted the articles by citation count from highest to lowest. And this number, 368, means that there have been 368 articles published within the last 5 years in Nature that have each received at least 368 citations. So if I click on this number, it might help you see this. It's going to show me all of these. Now, right now, it's only showing me the top 20, but as you can see, the number one cited article in the past 5 years was published in 2015, and it had 16,750 citations so far. And if you keep going down this list, the numbers get progressively smaller. And if we were to go all the way down to article number 368, it would have 368 citations. And then if you went to article number 369 in the list, it would have less than 368 citations. So what it means is precisely that. And maybe this would help if we use a journal that does not have such a high citation count. So one of the top journals in my field, in case you didn't see what I just did, there is a little hourglass symbol or a magnifying glass symbol next to where it says sign in. And if you click that, you can search publications. And publications means that you're searching for the name of a journal. So one of the top journals in my field is called Journal for Research in Mathematics Education. So if I search for that, I see it here. It has an H5 index of 27. So let's click on that and let's expand this out to 27. All right, so the number one cited article in the past 5 years has been cited 109 times. And if we keep going down this list, we see that if we go all the way down to article number 27, it has been cited 28 times. And if we were to go to article number 28 in the list, which it's not showing us, you would see that it drops below that so that it can't be 28. Because if it was 28, then the next one, article number 28, would have to be cited at least 28 times in order to make the list. So, for instance, here, this is article in the list, article number 26. Article number 26 was cited 30 times. But the H5 index can't be 30 because we don't have 30 articles that have been cited 30 times. We have 26 articles that have been cited at least 30 times. Here, we have article number 27 that has been cited 28 times. So we can say that the H5 index is 27 because we have 27 articles cited at least 27 times. And if we went to 28, we would need 28 articles cited at least 28 times. But article number 28, that's not shown here on this list, has less than 28 citations. So the H5 index can't be 28, but it can be 27 because there are 27 articles that have been cited at least 27 times. All right. And if we go back to this list here, whoops. Let's go back to this particular journal. It also reports an H5 median. This is the median number of citations for the list that is included in the H5 index. So in this case, the 27 articles. So the median is if you take all the numbers of citations and you put them in order from largest to smallest or smallest to largest, and you find the point at which 50% of them are bigger than that number and 50% of the articles have citations less than that number. So in this list, that number is 48, which is happening right here. So this article right here, if you look, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 articles that have a bigger number of citations than 48. And there are 1, 2, 3, 4, 5, 6. Go to the next page. 7, 8, 9, 10, 11, 12, 13 articles that have less than 48 citations. So 48 is the median number of citations for this list. So it just gives you an idea of how many citations there are among the articles in the list. It's a measure of center, kind of like a mean, but it's not influenced by extreme values. All right. Hopefully this helps you understand that a little bit. Another common metric is Scopus. So if we go to Scopus's website, I just Google search the word Scopus. It was the top result. And if you look over here on the right, it says, looking for free journal rankings and metrics? Oh, why, yes, we are. And thank you that it's free. Then you will see that you can search by title. Title meaning the name of the journal. So, Journal for Research in Mathematics Education. Let's say I know that that is a journal I want to look at. Oh, what happened? Journal for Research in Mathematics Education. There we go. Somehow I went to the Journal for Cancer. Okay, there it is. All right, here we go. Journal for Research in Mathematics Education. Let me click on the title here. Takes me to that page. And it says it has an SJR of 1.776. This is very different from the H5 index for this journal that was 27. And if you click on this little I next to it, it will tell you SC Imago Journal Rank measures weighted citations received by the serial. The serial is the journal. Citation weighting depends on the subject field, in this case mathematics education, and prestige of the journal, the citing serial, the journal. So, in this case, that number is 1.776. And this is one of the top journals in my field. So, just because it looks small doesn't mean that it's not good. Because remember, these things are dependent upon number of citations. So the smaller your field gets, the smaller this number will be by default. And the same goes for an H5 index. You can see they also have a metric here called cite score, which is a little bit more easy to understand. So cite score is, in this case, the citation count for 2018. All publications for that journal are all articles published in the year 2018. Add up all of the citations that the journal received in that year and divide it by the number of citations that journal received from 2015 to 2017. So you can see here it says there was 149 total citations in 2018, and the number of documents, and there were 61 documents between 2015 and 2017. So you could tell here that the citation count in 2018, 149 citations divided by 61 is how they calculate this 2.44 score. So it's a little more simple to make sense of. And then they've started it. They have a cite score tracker for 2019. 2019 isn't done yet, but they're providing, this is the way it looks right now if the journal received no more citations or if it didn't put out any more, actually the documents for 16, 17, and 18 is static, but the number of citations could still go up, which would improve this number. Okay. So the one that is cited most often, though, is this SJR score. It's a weighted citation count. Okay. Hopefully this is helpful as you think about journal metrics and what these things mean.